2016 question 1. A car has got an initial speed of u meters per second. It moves in a straight line with constant acceleration f for 4 seconds. It travels 40 meters while accelerating. The car then moves at uniform speed and travels 45 meters in 3 seconds. It is then brought to rest by a constant retardation 2f. Draw a speed graph for the motion. So we can represent this motion using the following speed time graph. So the car accelerates for 4 seconds. It then moves at a constant velocity for 3 seconds. And then finally it's going to decelerate to the rest in t3 seconds. The initial velocity of the car is u, and after 4 seconds then it's going to reach some speed v. Part 2 then, we want to find the value of u. Now from the time velocity graph, the car was travelling at a constant velocity for 3 seconds and the distance or the area was 45. So the area of a rectangle is the base by the height. So this means the area is 45 and this equals 3 times v. So this means v equals 15. So now that we know the final velocity of the car when it's accelerating, so the initial velocity is u, the final velocity is 15, the time is 4, and the area or the displacement is 40. So if we use s equals u plus v over 2 times t, we can work out what the initial velocity u is. So s is 40 and this is u plus 15 over 2 by 4. Now 2 divides into the 4 to give 2, and then we can divide 40 by the 2 to give 20. So 20 equals u plus 15, and this means u equals 5 meters per second squared. Now that we know what u is, we can work out what f is just using v equals u plus at. So this means 15 equals 5 plus f times 4, and this means f is 2.5 meters per second squared. Next of all, we have to find the total distance travelled. So we know what area 1 is, we know what area 2 is, we need to find out what area 3 is. So before we can find out area 3, we need to know what t3 is. That's the time taken for the car to decelerate. So when the car is decelerating, the initial speed is 15, the final speed is 0, and f is going to be the acceleration is minus 2f, so that's going to be minus 5, and the time is t3. So if we use v equals u plus at, 0 is going to equal 15 minus 5 times t3. And this means then t3 is 3 seconds. Area 3 is a is a triangle, and the area is half the base by the perpendicular height. So area 3 is going to be half of t3 by v. So this means area 3 is going to be half of 3 by 15, which is 22.5. Now the total distance is the total area, which is area 1 plus area 2 plus area 3. Area 1 plus area 2 plus area 3 is 40 plus 45 plus 22.5, which means the total distance adds up to give 107.5 meters. Part B. A particle is projected vertically upwards with a velocity of u meters per second. After an interval of 2t seconds, a second particle is projected vertically upwards from the same point and with the same initial velocity. They meet at a height of h meters. We wanted to show that h works out as u squared minus g squared t squared all over 2g. So you can see if we represent this information in a diagram, particle P is projected vertically upwards with some initial speed u, and particle Q then is projected upwards with initial speed u 2t seconds later. Okay, so because the time difference is given in terms of small t, we can't allow the time for either of these to involve small t. So we're going to let capital T be the time for particle Q. So particle Q is going to take capital T seconds. Particle P takes longer, and the time for particle P will be capital T plus small 2t. So we're going to start off with particle Q first of all. So the initial velocity for Q is u, the acceleration for Q is minus g, the time taken for Q is capital T, and the displacement for Q is h. So when they're both at a height h above ground, they will meet. So if we use s equals ut plus a half at squared, this means h is going to equal u times capital T minus a half of g times capital T to be squared. So this means h equals u times capital T minus gt squared over 2. So we can label this as equation number 1. For particle p, the initial velocity is u. The acceleration for p is minus g. The total time for particle p then is going to be capital T plus small 2t. And the distance or displacement for p is h. Again, using s equals ut plus a half at squared, this means h is going to equal u on capital T plus 2t minus a half g on capital T plus 2t all to be squared. So h is going to be ut plus 2ut minus g over 2 on, and when you square capital T plus 2 times small t, this gives capital T squared plus 4 small t capital T plus 4 small t to be squared. And if we multiply in by the minus g over 2, this means h is ut plus 2ut minus g capital T squared over 2 minus 2gt capital T minus 2gt squared. And we can label this as equation number 2. Now, with equation 1 and equation number 2, the left-hand sides were both h. So we can just equate equation number 1 and equation number 2. Now, when we equate the two equations, ut cancels out on both sides, and g capital T squared over 2 also cancels out on both sides. So we're going to try and get capital T on its own. Now we're just left with, on the right hand side, we're left with 2u small t minus 2g small t capital T minus 2g small t squared. So if we bring the minus 2g small t capital T over, you get a plus 2g small t capital T is 2u small t minus 2g small t squared. Now the 2's will cancel everywhere, and we can also divide everything by a small t. So on the left, we're just going to be left with g times capital T, and then on the right, we've got u minus g times small t. So this means capital T can be written as u minus g small t all over g. Now we can substitute this value for t into either equation number 1 or equation number 2. Equation number 1 would definitely be the easier equation to use. So we're going to replace capital T with u minus gt all over g. Okay, now with these two terms, u minus gt over g is common to both terms. So we're going to factorize that out in front. And you're left with small u minus g over 2 on u minus gt all over g. Now these g's will cancel, and we're just going to be left at u minus gt over 2. And we can write this u as 2u over 2. And 2u over 2 minus u over 2 works out as a plus u over 2. And so we're just going to get left with u plus gt all over 2. So the minus with the minus changes that to a plus gt. So we're left with u minus gt over 2 times u plus gt over 2. Now multiplying at the bottom, this gives 2g. Now on the top, we've got u minus gt times u plus gt. So this is just the difference of two squares. So this actually gives u squared minus g squared t squared, and then it's all over 2g in the bottom.